This video is going to talk about the first derivative test, which is a way for us to figure out where maxes and mins are. It's going to relate the function to its derivative. It's going to relate very closely to our increasing/decreasing video from earlier. So let's pretend that we have, this is our main function, and we're going to try and graph the derivative down here. A few things to point out is that at this point and at this point on the original function, we're going to have derivatives that equal 0. So if I just kind of go straight down from here, I know that the derivative has to have a value of 0 right there. And the same thing right there. It's going to have a derivative of 0. On the far left side right here, all the slopes of tangent lines for any point along here would have positive slopes, and here it looks like it's going to be a little steeper, so it's going to have higher values, and as we kind of get closer to that max, it's going to level out a little bit, so my values will be a little bit smaller for the slope. Same thing here, except I'm going to have smaller values here, and then it gets a little bit steeper, so it's going to be higher derivative values right there. Here, these are all negative slopes, negative tangent line slopes, and it looks like it gets to be about the biggest right there. Kind of is growing, and then it starts to decrease as it gets close to that min right there. So a potential thing that I might see for this could be what the derivative would look like, just a parabola, and that would kind of match up with what we talked through there. And so what I want you to notice is what can you tell about where maxes and mins might occur in the original function based on a graph of the derivative. And what the first derivative test says is that anytime the derivative goes from positive to negative, that's where the original will go from increasing to decreasing, therefore there's a max right there. Just the reverse at minimums. Whenever the first derivative goes from negative to positive, that's where you would see a minimum on the original graph, or the graph of the original function. So here's the actual test written out. It says we have to have a continuous function, and C is going to be a critical point, a place where the first derivative is 0 or undefined. If we can see that it changes signs, the first derivative changes signs from positive to negative, there's going to be a max. If it changes signs from negative to positive, there's a min. And if it does not change signs, that means that there's just no max or min there. Okay, just something like x cubed at 0. It just kind of keeps going. So we're just going to look at one quick example of how you would go through and use the first derivative test to find any maxes or mins, and also look at how we would justify. So if our function is x squared times e to the x, the first thing we're going to do is look for critical points. That means we need to take the derivative. Keep in mind, function times a function, we need to use the product rule here. So g prime would equal 1d2 plus 2d1. First function is x squared. The derivative of e to the x is just e to the x. And then plus 2 d1, derivative of x squared is 2x. So that is my overall function. I might take the time just to rewrite it here. Now you may not see this right away, but as we get through this process, you're going to figure out that it's better to have things being multiplied together than two things being added together. So I'm going to look for things in common, and what this has in common, both chunks here, is an x times e to the x. And then in the first place, or the first part, I have an x that's left over, and in the second part I have a 2 that's left over. And our job now is to figure out where that derivative could potentially equal 0, where it's undefined. Well, the first thing I can tell you is it's never going to be undefined, because we're never going to end up dividing by 0, and there's really no values that I couldn't plug in for x. So when I'm looking at this, I need to figure out what would make this chunk equal 0 and what would make this chunk equal 0. Over here, if I put a 0 in there, the entire thing is going to be 0. I can't put anything into this part and make it equal 0. This will always just be a positive value. And over here, in that last chunk, if I plugged in a -2, I would get a 0. So I have two critical points. So from there, we're going to make a sign chart for the first derivative. So maybe I'll just look at some easier ones here first. If I were to plug a positive 1 in right there, and go back to this derivative right here, this whole thing would be positive, and this whole thing would be positive, so in the end, my derivative would be positive. That means it's going uphill. The function is going uphill. If I were to plug in a negative 1, something in that range, this thing now would be negative, this would still be positive, so overall, this chunk is negative. And then if I plug in maybe a negative 3 for this part, this will be negative, this will also be negative, negative times a negative is a positive. So if you can kind of picture what this is going to be doing, I don't know exactly what it's going to look like, but I know that in this range it's going uphill, in this range it's now going downhill, and in this range it's going uphill again. So you can kind of see from there that there would be a maximum right here and a minimum right there. And that would match up with what we're saying up here. Whenever the first derivative changes signs from positive to negative, there's going to be a max. Wherever it changes signs from, the second part, from negative to positive, we're going to have a minimum. And so now we just need to write out an okay answer. But hopefully if that reasoning makes sense, now we just need to write it out using enough words and enough evidence that we know what we're talking about. So this would be one way to write out at least part of the answer. Notice that I'm saying g of x, I'm actually naming the function. I'm saying it's got to have a max at this value because, and then again, I'm using actual terminology here, not using it or anything like that, because g prime is greater than 0, g prime is positive on this interval, and it's negative on that interval. So I'm saying it's going uphill first and then downhill, therefore there's got to be a max right around there. A couple things to note, I'm calling it a relative max because I know that, just to kind of again sketch the function, it's kind of going up something like this. There's the max I'm talking about, it's going down, and then over here it keeps going up until infinity. So there are values that will be higher just in this little area that I'm talking about. Negative 2 happens to be a max. Sometimes you could have absolute maxes or mins. If you knew that it was just like a parabola that just kept going down, then that would have to be an absolute max. The other thing is, I do know that there's a min at 0. The phrasing would look very, very similar. You'd say relative min instead. You give a different x value. You would flip around these symbols here so that now you're saying it was going down and then going up, and you give the appropriate ranges. But that's the general way that you would write out an answer like that. Okay, jot down any questions. That is enough. You don't need to say first derivative test. You can just write this kind of reasoning out and they know what you're talking about.